We're asked to prove that e to the I theta is equal to cosine of theta plus I sine of theta, where e is Euler's natural number and I is the square root of -1. Now, if you recall from your calculus classes, you know that e to the x can be expanded as the summation from n equals 0 to infinity of x to the n over n factorial. So if we go ahead and substitute for x, we substitute I theta, we'll have e to the I theta is equal to summation from n equals 0 to infinity of I theta to the n over n factorial. So if we go ahead and expand that out, we'll have I theta to the 0 over 0 factorial plus I theta to the 1 over 1 factorial plus I theta squared over 2 factorial plus I theta cubed over 3 factorial, and so on. So the first term will just give us 1, because I theta to the 0 is 1, and 0 factorial is 1, so 1 over 1 is just 1. And then we'll have plus I theta, because 1 factorial is 1. And then I squared is -1, so we'll have negative theta squared over 2 factorial. I cubed is -I, so we'll have minus I theta cubed over 3 factorial. And if we continue this, we'll have terms like theta to the 4th over 4 factorial. And if we continue, we'll have terms like I theta to the 5th over 5 factorial, etc. So what we're going to do is we're going to notice that some of the terms are purely real. So the 1, the negative theta squared over 2 factorial, the theta to the 4th over 4 factorial, etc. And there are some terms that are purely imaginary. So we'll have I theta minus I theta cubed over 3 factorial, etc. So I'm going to group all of the real terms together. So we'll have 1 minus theta squared over 2 factorial plus theta to the 4th over 4 factorial plus ... And then I'll group all of the purely imaginary terms together, but all of them have a term in common, namely I. So I'm going to go ahead and factor out that I. So I'll have I times theta, will be our first term, minus theta cubed over 3 factorial plus ... Now you'll notice that the real term, this term right here, the 1 minus theta squared over 2 factorial plus theta to the 4th over 4 factorial, etc., that's just the Maclaurin expansion for cosine of theta. And then plus I, and then this term right here, the theta minus theta cubed over 3 factorial, etc., is the Maclaurin expansion for sine of theta. So we'll have plus I sine of theta, and the proof is complete.